Okay, so next we have Lana Malic, machine learning engineer at Endava. Lana will be presenting AI agents, the future of autonomous decision making in business and beyond. In this session, Lana will explain the principles and mechanics behind AI agents, focusing on how they enable continuous hierarchical decision-making. She will share real-world examples across industries such as finance, healthcare, manufacturing, and energy, showing how AI agents are improving operations and fostering innovation. Lana will also discuss the future potential of AI agents, including their ethical implications and role in solving complex problems. Please give Lana a warm welcome.
Hello, everyone. Okay, so okay, sorry. I'm going to start off with this quote of Andrew Ng saying that, dear friends, I think AI agent workflows will drive massive AI progress this year, and perhaps more than the next generation of foundation models, and this is an important trend, and I urge everyone who works in the AI to pay attention to it. And the reason why I put this is because I truly believe that when we think of the future development of the AI in general will be in the hands of the AI agents. So today's agenda is to talk a little bit how we kind of moved from this developing of these monolithic AI models into thinking in this compound and modular way to have these systems that have integrated these individual components to have a more powerful system, and about AI agents in general, how they work, the multi-agentic frameworks, what is the reality of today, and what are the real industry applications and the frameworks that we have, and maybe get a little bit philosophical into, thinking how will the future look like, and what does the future hold when we think of this general intelligence and having these autonomous agents. So when we think of having these single structured AI, when the AI became hype and when we, moved into this direction of developing the AIs and having these, powerful models, we were thinking of having, a model that performs really well, that we can integrate it into the system, that very much, did one thing that is very good at. And thinking it this way, there's it's very much data limited, and if we want to make it more flexible to adapt it to different kind of situations, then it's just you have to have additional training and additional work to do so. And what we saw with just having, for example, we know that we could never treat LLMs as knowledge sources, and we overcame these huge obstacles with just having the RAG, with just including what we already have that already existing, the semantic retrieval with the generation capabilities, where we overcame this huge obstacle with just integrating the components that we already have. So when we're thinking about combining these things together and making things modular to work together, we can enhance much more capabilities in general in the systems, where we could really just work with what we already have. And I was mentioning RAG also when we think of having this multimodal AI, and also this is how the idea was born when we were talking about the AI agents. So here's what we can see with how this approach is powerful when we're thinking about what we care about in the AI. In the end, it's what kind of quality of the output we have. So this is the main thing we're interested in. And when we're looking at this example of how the GPT 3.5 and GPT-4 models performed in this zero shot generating the code, with just the model, we can see that it's just somewhere around 45%, and it jumped almost over 85% with integration of the tools and using planning and using this agentic approach, using the exactly same model. So this is fascinating that there was no improvement, meaning that there is that we try to improve power of this thing that is mostly responsible for the thing it's doing. So when we're talking about AI agents and what essentially they are, so a lot of things are today called AI agents, but in order to have, consider something a smart AI agent, it needs to have the AI model behind the scenes doing its thing, doing the reasoning, the making of the decision, and acting as a brain of an agent. It has tools with which it has the ability to act and to perform, and it has the memory and the ability to access it and to use it for have this reasoning enhanced. So let's talk more about the reasoning of the AI agents. So I'm gonna be talking mostly about, when I say AI agents in these presentations, I will be mostly referring to LLM agents. And the reason for so is that when we think of other agents, they have been trained in these strict environments, and they are also very much data limited. And when we think of how humans operate in the world and how we have this general world experience and how humans think, we can, our first association is humans have this internal monologue that is represented with the words. So we can capture, essentially this human experience in the text and to mimic this general knowledge mostly, with the capabilities of the LLM. So we know for sure that LLMs cannot actually reason and that they don't know actually, how things are, what is actually happening, but it's, probabilistic generation of the next token. But in the training data, they are relying on the human logic that they saw, that is semantically captured in the training data. So this is why the LLM has now, when it comes to, representing of capturing this experience from which it can, reason the best on this general approach, the LLMs are probably the best way to do so today. So the main task of the brain of the agent is, when it's given a certain objective, it needs to analyze it. And of course, with the tools and with its capability to act and perform, it needs to know, what are these exact steps to take in order to achieve a desired outcome. Because again, when we are thinking about a certain problem, we might have this, initial thought, or we might analyze it further. We might think of, what are the outcomes of these additional steps, and we're just trying to refine in this thinking process, what is the best way to actually, have the most probability to achieve a certain outcome that that we want to achieve. So we need to identify what are these steps, in which order should we execute them, and of course, if something is happening alongside, we need to adapt to new changes to adapt our reasoning process. So here in this left picture, we can see, what are exactly the methods that we're trying to enforce with the LLM to have this reasoning capability really powerful. So we're not trying to just utilize this first thought that came to mind, but we really want to enforce this chain of thought thinking. So if we have especially really complex task, in order to, have higher probability of accuracy, it's always better to think in steps and to really granularly approach the problem. And when we know outcomes of each individual steps, we're more highly to achieve this final output that is correct. So we can have this chain of thought when we really revisit each of our steps of thinking, and also so we can have this chain of thought, a way of thinking, or even having this train of thought, which is, having this tree architecture of these chain of thoughts, to have multiple possible steps that we can consider. And what we saw with these enhancement of the LLMs, recently the OpenAI released the O1 model, and their main thing was, to their main word when it comes to this O1 is let's have better reasoning capability. And what they did is actually they were trying to enforce this chain of thought in their fine-tuning approach. And we can see here in the competition math, competition code, and PhD level level science questions, it heavily outperformed GPT-4o. So when we say agents, tools, and their capability to act with them, today what we are seeing with the frameworks that we have today, we can think of these tools, especially when we think of software, as having capabilities to perform a certain action, such as web searches, doing calculations, executing code, accessing databases, accessing different AI models, which can be very powerful, or accessing interacting with other systems via APIs, which is very much, everything that you need to do is very much captured in the tool itself. So you don't have to rely on the LLM or on the AI model, to do actual thing, but you're only relying on the tool that it's choosing that is choosing to perform certain action. So its objective is to identify this function and to identify what are exactly the parameters in order to execute this function. So let's see here, for some of you who didn't have experience with the actual agents, in the code itself, we can see here a simple example of LangChain tool execution. So we know that LLMs were not good at actually doing math and calculating. So here we do not, again, need to rely on the LLM to do this for us, but we here have the example of a class that does hypothesis calculation. And here on the right picture, when we see this input of the user to calculate this, in this chain of thought, we can see that it successfully just identifies based on the description above. So this is how we approach, how to tell LLM what is this tool about. We can just do the description in the language itself. So the LLM then can reason and see, okay, this is the tool for this certain calculations, and based on the user input, it can identify successfully what are these parameters that I need to input into this function in order to execute it. Also, one maybe even the most important thing when we think of having this really, really high capabilities of the agents is to have a very efficient memory module. Because again, when people think about something and they want to act smart and know how to do something, they capture their knowledge capabilities from the memory itself. So the agents in general, they have this short-term memory, which is like a working memory of the current conversation, where they have to know, what is the input to the agent, what is the context of current thing that is happening in order to know how to perform. And it has this long-term memory that is persisting across multiple interactions in order to store the experience of this interaction between the user or this input data and in ongoing interactions. And the main thing why this is necessary is definitely to maintain the context, to learn from the previous experiences, to improve the performance over time, and to provide these personalized responses based on the user history. And we will talk about this a little bit more later. And here we can just see, the final overview of, how are these components assembled with the agent. So when we say multi-agent frameworks, of course, when we're thinking about, if we have one powerful thing, why not having, multiple things combined together in order, to have things even better. And what we saw in general, when we have an agent that has a set of tools in order to do something, if there's a lot of tools that can do something, if we have a highly complex problem, we need to, there can be a lot of problems for one agent to handle all of this. There's just the mistake rate is much higher than to perform the exact same thing with the multi-agentic workflows. And here we can see that how in general are these agents combined together. We can have these hierarchical agents where certain agents are on top of the others, so others are dependent on it, or we can have this like orchestrated agents that their main purpose is actually to navigate a certain task to a certain agent. And we can have these highly specialized agents in very specific things, so they can, just be responsible for one thing. And in this way, we can really, tackle a complex problem in this way that we can, approach it from this hierarchical perspective. And this is good for, again, specialization, parallelization of the processes where we don't have to wait for the output of certain tools, with the same agent, but we can, have these agents performing simultaneously and then combine the responses together and so on. We have a better, in general, performance. We can, the customization is better. We just, approaching and having, additional specialized agents, better dynamic decision making, and it's much more, it's easier maybe to track what's happening when you have it defined like this, to have more control over this interaction and the flow of the information. So let's see how this is actually implemented, in the code and what's happening today on the market. So when we say AI agent frameworks, they're actually these software platforms that are designed to simplify this creation of these agents. So we have on disposal these components that help us to create it, so that we don't have to, ourselves dig too much into the code space. So they help us with this building of the agents. Here is an overview of what are the frameworks that are mostly popular today. And the thing with them is that all of them have certain aspects to them, and all of them have their maybe pros and cons. And in the way we're approaching of selection of this framework, it all depends of what exactly is our problem. So, for example, some of them here, we can see the AutoGen that is very, even though it's not open source, but it's very good with this multi-agentic conversation. Something that LangGraph was trying to achieve is that there is always this trade-off, with also how much control you want to have with the agent itself, or how much you want to rely on the framework. So with the LangGraph, for example, with the LangGraph, we can ourselves define much better this correlation between the tools and the agents and these states that are represented. These we can have this like stateful machine that represents each step of the process, and how are they, we can condition them ourselves in order to have much better control over the flow of information and what's going on. Also, we can, how the companies are trying to think in order to have a better adaptability is also, not just having this linear flow, but also to have this cyclical approach where we can, agents can revisit their steps if something is not correct, or enough information was not retrieved, and so on, so that it can go back and refine the process in order to achieve what it should do. So when we see today, when we're thinking about, having these intelligent agents and so on, the reality of today, there are a lot of industries that here are stated. They have these agents implemented, whether it's an LLM agent or different simpler kind of agents. But mostly what's happening in the field of LLM agents, they're mostly, using these virtual assistants and having this customer service. They're implemented in the customer service because they're mostly relying on the user input. So it's mostly like this either conversational style. And we can see here that it's very much an ongoing trend, and probably it will be, in the future, and a lot of companies will adapt this assistant agentic approach, and we can see the revenue across the years and prediction for the next one. And also we can see that it's happening a lot of in any kind of digital labor in the research, and also the code generation, where we just don't have anymore this just giving us snippets of the code, but actually gluing them together. And really there is a lot of improvement there as well, to have these agents having all of this, combining together these things. So they of course seem very powerful, and when we say agents, it's a great thing. You don't have to have anymore the AI model output having telling you something, but actually they can do it for you. So it's really a game changer when we think about it, and it can be very powerful. But of course there's a lot of challenges that are happening today. So one thing is definitely scalability. So when we're thinking about having these multi-agents, and also there can be, it requires a lot of processing power. There might be, a lot of latency issues and so on. It might be, not so easy to integrate these agents into existing systems. One big thing is accuracy and reliability. There is, of course, some approaches, how to handle this in order to have, certain tests in order to achieve, better accuracy and to rely more on the output of the agent. But it's still an issue. And of course, this memory limitation and contextual management. Because for now, especially when we're talking about this long-term memory, so the thing is, when we think of storing this whole context of previous conversation and everything, if these libraries offer some kind of memory management, it has the size of the context. It's limited, and if we want to have it larger, then we need to tackle better this problem. How can we efficiently retrieve information from this context if it's higher, if it's not cut? We can either cut it, summarize it, or retrieve it in a certain manner, but it's still not perfect in a way that you can really have this memory management well, in order to really have these reasoning capabilities enhanced. One thing is definitely also security. It really depends on how much capabilities you give to the agent and permissions. How do you define these tools? Some of the things that are can happen, are these if it's accessing some kind of sensitive data and so on. If you give it too much of this autonomy, then it's a trade-off. And also one big thing is, again, especially with these multi-agent frameworks, workflows, is that if you have one thing that is dependable on another, then if there is even minor errors happening, with each agent, when you think of the whole process, then these errors can accumulate. It can just go wrong, in one direction, and the whole thing, can go wrong. So this is definitely an issue. So when we're trying to think, when we think of AI agents, they're very impressive. So we can think a lot of things happening. When we're trying to have this, like, especially when we're thinking in a way, how can we really achieve having this AI agents that would have this cognitive general power, and when we're thinking about these autonomous agents, I truly believe that the way we approach, in general, technology, science, engineering, whatever, there are always some kind of, the things that are really working are almost always mimicking, what's happening in the nature itself. So the neural networks are trying to mimic, how the things are happening in the brain. So I found this interesting, how some of the proposals of how can this, for example, memory storing and retrieval be tackled based on how these hypercolons in this human brain, in the human cortex, how they store this sensory input and retrieve it in this hierarchical associative manner, rather than just having this, mapping that we can see today. So this is something to think about. How can we, what are the approaches and what is the way of thinking? How can we solve the issues that we stated before, and how can we, because the capabilities technically can seem limitless when it comes to if we really approach something very much granulated, we can have really a lot of we can see that it can happen in the future, and maybe even in the very much soon future. And what we will definitely see is having these multi-model, multi-agents. And again, now when we're talking about these LLM agents, we're mostly talking about having this, user input data, but in general, it can have a lot of different data as an input that would really, the data itself really defines the AI itself. So we can have a lot of kinds of data. And also, again, when we're thinking about having us as humans this capability of interacting with the machine or with the internet or whatever, there's then this technical possibility of having the agent to have this interaction and to have this, tool awareness layer, and to have this, self-discovering objectives, dynamic learning, and so on, self-upgrading mechanisms, overcoming these context and memory constraints, as we've discussed. Also, I saw that something that was happening, for example, how should we represent this memory of this like general experience of the human or the agent, is that it can be not just like the textual, it maybe should not be captured as a text, but also captured in the weights of the model, where there's a fine-tuning based on the conversation history that the agent had to capture this in the weights of the LLM that the agent is using as a brain. And also, to have these interconnections. This is something I didn't have I haven't discussed that much, but this, how are these agents, multi-agents, communicating together, how they share this experience, because this is still a problem. And of course, the ethical frameworks that are something definitely to be discussed in the future. Thank you.
Okay, so are there any questions for Lana, maybe?
Thanks for the nice presentation. As you mentioned, it's very important, like, to have an AI model for reasoning, because wrong AI model for reasoning will always lead to wrong outcomes. Wondering if you have tried any open source model that is good in reasoning, as good as the OpenAI for all.
In my personal experience with the agents, I did not use any open source models, strictly the OpenAI ones. So I don't have the answer to this.
Thank you.
Hi. Do you have maybe any recipe to share about finding a good trade-off between complexity of an agentic framework in terms of a number of agents and having a low enough execution time?
Again, it really depends on the problem that you have. This is something that, when we think of actual issues that we have, it's always a testing approach to see what kind of way to over-complex in this to multi-agentic approach, or to kind of tackle this in the space of the tools. It's a testing approach when it comes to the reality of the project.
Hey, thank you for the presentation. So I wanted to touch on evaluation or how are, for example, people coping with evaluating these agents? Are, are they, for example, making some synthetic data sets to evaluate the outputs of these agents, given that, they are in JSON output? And so, yeah.
Yeah, okay, thank you. In general, how to even evaluate or see is the response, is it not only good enough, but is it, actually achieving what it's trying to do? We have a lot of systems such as guardrailing that is also can be dependent on the LLM that is revisiting, what was happening if we have good set of examples, what is, good and bad output. And also there is a lot of this human feedback also happening behind the scenes where we can actually evaluate what's happening. So it's a combination. And now with other models as well.
Thank you.
You're welcome.
Thank you for the presentation. I have a question related with the knowledge of LLMs nowadays, because they have a lot of knowledge, but sometimes can be conflictive with the tool usage. So how can we solve the conflicts between the tool information and the model's information? With only prompts, or should we do something else to maybe prioritize tools or maybe prioritize models information?
Yeah, so how can we approach this in general to have the tools represented well, have them described well, and just this whole designing of the tool process, it really, how we assemble things together. Again, different frameworks offer different kind of capabilities. How to enforce of having, the flow that we want to achieve is we might not want to only, rely on the reasoning of the LLM, but to, have these correlations are defined ourselves, and some of the frameworks, really do offer this capability to really define, okay, this tool can only, go to the next tool, this agent can only go to this one, and so on. So we can kind of have some kind of control over it in order to, avoid having this flow that we do not want to.
Thank you.
Thank you.
I only use the open source model for that. So, but from my experience with agentic workflow, I find it very difficult to get the LLM to use the proper tool and not hallucinate an answer or, yeah. Or, yeah. Do you have any idea how to force the LLM to use proper tools?
You've mentioned you only worked with open source models. My case is contrary, so I only used non-open source tools.
But do you also have this issue with OpenAI model? Or
sorry, can you repeat?
do you also face this kind of problem with OpenAI models?
Definitely, but from my experience, it performed good. It's definitely you cannot solely rely on this. You have to have some kind of checkers behind the scenes. You have to have some limitations and restrictions you want to impose. Whether it's an input or output thing, but some things that are glued together, they can perform well enough with the non-open source models. Thank you all.
Okay.